Good morning, everyone. Well, thanks for coming. It's a pleasure to see everyone here. Many familiar faces, some new ones as well. And, we're going to talk about the connected water utility and what that really means. I would say that a lot of you are already starting that journey, and it is a journey, right? Because it takes time to get there. But I think everyone here already has some type of automation or control system, right? So there's sensors already at work. You're doing something with that data, hopefully, that's coming in, right? But it is that journey, and we see it every day, even in our homes. And I'll talk about that in the end. How my home's kind of connected, but that just shows you that sensors are very cheap and very accessible. And it doesn't mean always that you need to have controls. That's a big part of the equation. But in our utilities today, there's still a lot of areas that are, let's say, dark, that we might not be able to see everywhere throughout all your distribution network or collection systems, right? But that's starting to change. So let me start off with this, a few questions. This is a survey to over 150 organizations done by McKinsey & Company. And it talked about, big data, sensors, and all that. So what does that really mean? So the three questions they asked. First of all, do you understand the impact of IoT, Internet of Things, on your industry or business model? What do you think people said to that? Do you understand? No, right? No? Yeah. 12% said they understood it, right? Yeah. The second one, will adoption of IoT disrupt your industry? What do you guys think? Yes, right? Me? Over 70% said yes. Now, I think that the third one is really interesting. Will this disruption happen before 2020? That's like next year, right? What do you guys think of that? Some people say no. Oh. Some people say yes. Okay, let's see. Almost 80% said yes, that there's going to be some kind of impact or disruption, right? So that's pretty interesting. It's because we're starting to see it already, right? And we'll see some examples around that. The challenges that we face every day. I don't have to go into details. You are all familiar with this, right? Whether it's leakage, pipe bursts, overflows, flooding, energy costs, of course, right? This is something that you deal with on a daily basis, right? So we're going to see some examples around that. But first of all, here's some customers talking about how data is important to them. And when we talk about water at OSI Soft, it's the entire water life cycle. And you can see Barrick Gold there, largest mine, gold producer in the world, and their whole drive is to go towards $700 per ounce of gold and being digital in terms of their mines. But here you can see an inset of when they took over a mine and there was a lot of pollution happening. That's cyanide coming in through the river. They put in a wastewater treatment plant, cleaned it all up, right? And you can see the difference right in there. Veolia Water, the largest water company in the world, a customer of ours. The first thing that they went after was looking for leaks and reducing their energy costs, right? And you can see the impact that they have there. This is in the Paris region. 7% more leaks found, reducing their baseline energy by 6%. IBM, this is a chip fabrication facility, over $1 billion a year, producing microchips in all our phones and devices. And they have to create ultra-pure water, which is very expensive. And so they wanted to reduce the amount of water that they're consuming and also make it cheaper to produce that ultra-pure water. By looking at all the data, they've been saving, I think since about 2012, $10 million a year on those costs. And lastly, Thames Water, a massive water utility in London. So whoever's been to London, England, Thames Water treats all the wastewater there and provides all the drinking water. Massive organization. And they looked at all their energy spend as well and were able to reduce that by 10%. So millions and millions of dollars per year. And we'll get into some more details around some of these examples. Now, as part of that digital journey that we're all on, we face and see a lot of data, right? And the typical three big challenges around data is volume, variety, and velocity. So here are just some examples how some of our customers are managing that. Veolia Water, they created their own water meter. Each meter measures 50 different parameters in real time or near real time. They rolled out 700,000 meters. That's 35 million unique data streams of data coming in, right? So that's pretty big volume, right? Variety, E.ON, energy producer, power producer over in Europe, and they have a lot of different tags, a lot of different data formats and so forth, a lot of different protocols, and a lot of different locations, so variety, right, that they're managing. And then thirdly, velocity. We all have major pumps and motors, and some of us have vibration monitoring on that. And some of those sensors can monitor over 200,000 events per second, right? So that's, you know, pretty good velocity, right, around that. So this is something that we see every day. But with that, we also have other systems, a lot of business systems. We have all our controls, automation, manual data, data loggers, meters, all that OT, operational technology side of things. How do we manage that and make sense of that while we also have all these business systems? We have our asset management system, geospatial systems, right? When you all signed up, you answered those questions, right, the surveys. And everyone said they had a GIS system, a CMMS, some kind of financial system, automation controls, manual data, right? It can be pretty messy in terms of managing all that. And as you know, OSIsoft, we make the PI system, and we, out of the box, are able to bridge the gap between the OT and the IT worlds and start making sense of that data. And today, as you know, you'll hear a couple of our, three of our customers speak about that. But I'd like to dive into some examples specific to water, wastewater, and see how they're managing and actually using that data to make a smarter, more informed decision every day. Right, and that's important. Because I remember when I, used to be in controls and automation, we'd probably be one of the last people in on a major project. $1 billion plant, we're kind of last ones in, putting in the controls and automation, and people kind of forget, like, we put all this, sensors, all automation in, and what do we do with it? Well, we generate a lot of data, but how's that gonna help me if I'm in operations? Or if I'm running a utility, right? So let's look at some examples as we go. But before we do that, just one more slide here. Innovation is key. This was done by the AWWA in 2017. They surveyed a lot of the members, and this is what they found, that culture is a big part of that. And what I see here today is the leadership that we're looking for in the industry. Coming out to these events, and networking with your peers, and being those leaders in terms of showing, what you're doing in the industry. So the first example I have is the city of Calgary. Back in 2013, they predicted they were going to have a major flood. The city has 2 rivers that run through it, and it's prone to flooding. So they actually have the ability to divert water flow. In PI, they set up a bunch of calculations and notifications based on many different parameters, including the weather forecast, the river levels, the volume of the water coming through. And you can see here in this upper right, a lot of data from Environment Canada. So they have snowpack melt, the levels, and so forth. And they predicted that they were going to have a massive flood to the point where they needed to evacuate the downtown core. So they actually asked the mayor to say, hey, look, let's do an emergency evacuation, and they moved everyone out. I remember actually watching the news, and I saw like a Ferrari floating down the river downtown. But what's important is that that could be replaced, right? There were no lives lost, right? So imagine if you didn't get that type of warning, and there could be a loss of life, right? It could be a lot more detrimental than, you know, just things that could be replaced. But that's something that they did, and they saw this about 48 hours in advance, right? San Francisco Public Utilities Commission. So just, you know, not too far, straight north of here. You can see there's a map here. And in this map, there's a couple of things. First of all, they didn't have visibility. And when they put in the PI system, they now are monitoring all their wastewater treatment plants. And what's really important for them is sewer overflows. So last year, they did a presentation about biologists needing real-time information, right? And some of you saw that presentation. There they talked about how can we prevent sewer overflows, because they have combined sewers, just like many of us here. So they have all the calculations in the system that actually calculate and tell them and predict if an overflow event's going to happen. And if it does, because you can't always prevent it, they have the ability to kind of move water around. They have these boxes around the area here that you see on each side. And they kind of move around and distribute flow so they can kind of regulate the amount of flow coming into their wastewater treatment plants. But sometimes you just can't avoid it. And in those situations, their biologists actually have real-time information available to them to see what's been discharged. You know, we have abilities to calculate the volume that's been discharged, when it started, when it stopped, and so forth. So pretty interesting. And they, of course, they have the ability to drill down into their facilities as granular as they want, down to the point where they're looking here, in this case, at individual pumps. And one thing they did was they did do a pilot project where they said, hey, why don't we start servicing our pumps and major assets based on condition instead of, well, periodic maintenance, right? I think that's the most simple thing, periodic. Every 6 months, run out there. But what turned out in their case was they were over-maintaining a lot of their pumps and assets. And they're just wasting labor dollars where they could use those hours somewhere else to be more productive. So for them, 100 pumps, and they have thousands, over 2,000, 100 pumps meant a savings of $400,000 per year, right? So you can start to imagine how those savings can build up over time.